You're off to a good start.
Is it working?
It's
Yeah.
All right.
working.
You didn't even have to like do that thing where you have to drop the call and then come back in because you don't have permissions to share on Zoom. I had to do that yesterday.
I actually did that right before you jumped in, Christy. I was doing a dry run with Planky, and it ran me through that, and I was like, oh crap. So I was 13 seconds more proactive. Good evening, everybody. Welcome to the AWS Portsmouth user group. This is the revitalization episode 2, Electric Boogaloo. Tonight we're going to be talking with Rajat. We're going to be doing modernizing IoT solutions using named shadow implementation. If you want to join the Slack, feel free. If you go to awspug.slack.com, you can join the Slack and we can chat there. If you want to see what's going on with the community, you can also follow us on Twitter. And if you go to awspug.org, you will see absolutely nothing because Christy and I have not fixed the website yet. We stink. It's on both of us. Let's be honest. We're both culpable for not fixing that. So don't go there. But
clear. It's not on me, right? I'm completely not responsible for this.
When we divvied up the list, you did not want the website responsibility anymore, so it is on me and Christy.
You heard it here first.
Yeah, it's recorded now, so.
A huge shout out and thank you to our sponsors, Worldwide Technology and AWS. If you want to get your name up on the sponsorship logo channel, please feel free to reach out to us. We will gladly love to have a conversation with you. Space to present, swag, food, cash. Always cash is king. Let us know, and we would be happy to work that out with you. I messed up part of the thing, so let's cut this over. I'm going to stop sharing right now after we get it started. Time to learn. All right, Rajat, if you would please share your screen, and hopefully you didn't just get a brand new Mac too.
No, I have the old one, probably 7-year-old from Amazon, but it's working good. So all good. I'll quickly share my screen. Oh, it says that host disabled participant screen sharing.
Hold on, I've got to make you. See, I knew I was going to screw this up. I'm going to make you a co-host.
Sure.
That way you can have all the powers.
Is there any time limit that I should be aware of to complete this session of presentation? Definitely want it to be interesting.
Less than 4 hours, longer than 30 seconds.
Okay. That's flexible. I like it.
Well, as long as you're not want to talk for 5 hours, then it wouldn't be flexible at all.
Yeah. Are you able to see the right screen, folks?
Yes, we can see your screen.
Awesome. So yeah, I'll quickly kick off. So hey everyone, some of you may know me, some of you may not. My name is Rajat Mathur. I'm a senior solutions architect with AWS, and I'm based out of Boston, Massachusetts. And I've been with AWS for 7 years now. And through these years, I have worked with multiple enterprise customers, again, as a solutions architect, to help them with their business transformation, technical enablement, and to learn more about what that migration journey looks like, right, from on-prem or like any other cloud provider to AWS. So I think I joined AWS back in, I think, Q1 2016. And right before that, right before I joined, we launched our first AWS IoT service, which was known as AWS IoT back then, but AWS IoT Core now. So right after I got onboarded, that was the time where I started to work on that service as a part of my role. And yeah, since then, I have been really playing with AWS IoT services. So yeah, good to be here today. Will not be covering a lot, but a very specific topic that I always, I'm very excited about is like name shadows, right? So name shadows is relatively like a new and a powerful feature within AWS IoT Device Shadow suite that gives really true value to your IoT use cases. And we will cover more in a bit to learn like what are the advantages and why it should be used and how it should be used. And of course, like I want this session to be interactive. So I would appreciate any questions that you may have for me. And just stop me if you have any questions. So in terms of agenda, just to quickly go over it. So, I mean, I'll be talking about a brief introduction to what AWS IoT Device Shadow service is actually. Some of the challenges that we have gathered through our customer interactions, right? Challenges around like the native classic shadow implementation that was offered as a core like part of the device shadow service. And then once we talk about those challenges and limitations, we will definitely talk more about when and how name shadow feature was launched and how it helped you resolve some of the challenges that we talked about. And then I'll be going over some of the design approach that I recommend to you and some of my customers to think about modernizing your current IoT footprint. And if not modernizing, at least thinking about utilizing name shadow feature for some sort of asynchronous mechanisms between your devices and applications that you may want to have interaction in between through AWS IoT platform, right? And then last but not the least, I will be talking about one of the customers that I directly support as a solutions architect, iRobot. Would definitely not be introducing them. I'm sure like most of the people would be knowing who iRobot is and the magic that they have been doing in IoT and robotic vacuum space, but we'll be quickly going over how they migrated away from their classic shadow implementation to name shadow. So just to give you a brief introduction to the service, right? So AWS Device Shadow is a part of an offering that comes with AWS IoT Core service that really enables your cloud and mobile applications to easily interact with your connected and registered devices, and these devices can have some intermittent issues because we are talking about IoT, right? We are talking about field devices. We are talking about devices that might be in a particular industry, that might be in labs, that might be out on the field, agricultural field and whatnot, right? So Device Shadow really gives you that meaning where you are able to even establish communication when there is intermittent access issues, right? It allows you to maintain the latest state information for each device that you have connected with the platform. And the type of state information that it helps you gather totally depends on you. So it depends on you what type of device or state attributes you want to keep track of based again on the distinctive use case that you might have for your own business, right? So you can think of IoT device shadow as a virtual representation of a physical device in cloud. So initially when IoT Device Shadow was launched, for each IoT device that you connect as a thing, there is a default classic shadow that's created for that thing. So essentially, a virtual representation of your physical device is what AWS IoT Device Shadow is to begin with. Now, as I mentioned, right, this shadow service enables you to synchronize set of state variables between the cloud side of things and your device, right? And now, because of the device shadow, your applications, your IoT applications can read the device state even when they disconnect it. So you can also consider it like a persistent storage that we provide as a part of the device shadow service, where you want to push like a state change known as desired state to your devices. It can be sensors, it can be smart vacuum, smart home, or whatever it is, right? So you can push that change and the device can pick up that change when they are back online from a disconnect issue, right? So that's the power that it really delivers as a part of the service, right? It also allows your application to set device state, as I mentioned, and have it retrieve when the device disconnects. And the way the service maintains these state that I was talking about is by creating a JSON-based document for you. So if you technically call what a device shadow essentially is, it's like a JSON document that you create based on the type of attributes that you want to control for the devices that you're connecting with AWS IoT. And just to mention here, like there are two types of device shadow that we offer today. Classic shadow that was launched when we initially launched AWS IoT Core back in 2016. And recently, I think back in 2020, we launched an updated device shadow known as name shadow with certain more capabilities. And that's what we are here today to talk about. We'll just give a quick pause to see if anybody has any questions so far. Awesome. So in the last 4 years, I particularly have worked with a lot of customers, and as an effort to that, right, I got a lot of feedback from these customers, and overall, I mean, talking about to the entire IoT community we have within AWS, we did realize that there are some existing challenges that the customer are encountering by building their IoT solution on AWS. By using the native device shadow offering, that's classic shadow, right? That's like a single shadow representation for your IoT device or thing, right? So first thing that was called out and that we understood was cost matters a lot to our customers, right? And cost matters to everybody who are out there in business trying to build something and try to bringing like true value to their end users, right? And device shadow as a service can get expensive when used at scale. Now, again, while using the classic shadow feature, of course, right? Because the way device shadows are built is based on the size of the shadow document that you create, right? Now, again, it depends on your use case. Your document can range from 1 kilobyte in size to, let's say, 30 kilobyte in size, right? That's like a maximum upper limit we had with the, we have with the JSON document upper limit that you create with device shadows, right? Now, based on the kilobyte of the size of these device shadow, you get billed. So basically, 1 kilobyte of size of each document is counted as one API operation. So let's say if you have like a 30 kilobyte of classic shadow created for IoT device shadow, then you will be charged that on based on like 25 API operations. And I think the cost is, I think, $1.25 for million of such operations, basically. So overall, it is cheap. But when we talk about use cases that are heavy on maintaining these device state, it can become costly, again, as I mentioned, when operated at scale, right? So cost optimization was effect that we saw in the first feedback that we received from the customer, right? The second feedback was around the shadow size limit. So by default, the device shadow size limit can be 8 kilobyte in size, right? Again, that's a lot when we talk about traditional IoT use cases, but based on the updated use cases that we see today around industrial IoT, smart home applications and whatnot, this shadow size can substantially increase, again, based on the level of control that you want to have into these attributes that you are managing and maintaining, right? So 8 kilobyte was the default size. Again, by submitting like AWS limit increase request through support, you can get this to increase up to like 30 kilobyte. But we were still hearing some feedback from customers that is also causing as a limiting factor. Because again, there are many use cases, again, depending on the type of the use case you have, people were interested, customers were interested to monitor their device information. They were interested in monitoring their user information. And furthermore, segregation around the type of the device information they're getting, they are trying to build more and more use cases, right? Those use cases can be predictive maintenance. Those use cases can be firmware updates, maintaining and managing firmware updates for their IoT fleet, or like, building analysis on the type of the data that you are gathering from these devices, right? So we did realize that, customers are complaining that there is a limitation around the size that is causing them to maybe, that is becoming a limiting factor for them, right? And the third feedback that we received was around access control. So imagine like having like a single classic shadow for your IoT thing. All the set variables and the state attributes are within that same document, right? Now, if you want to make an update to a single attribute, you will have to have access to the entire shadow document, right? So there wasn't any further granularity provided to you where you are able to just change or view the attribute that was of your importance. And when you are viewing it, you are making like a update API call or a get API call to basically the shadow service, right? And you are basically paying for the entire size of the shadow that you are using. So once these challenges were come, right, internally, we did realize that, and as you know, like 95% of our products are driven by customer feedback, right? So internally, they were like many chit-chatting, and to overcome these challenges, AWS IoT Service, as I mentioned, in 2020, launched the name shadow feature. And what this name shadow feature was, this name shadow was a new capability that allowed user to create multiple shadows for a single IoT device. Now, IoT device often have multiple state data, as we were talking about, right? Such as user settings. It can be manufacturer configuration, or any operational status that you want to get out of the type of the device that are connected, right? Now, to manage and maintain these type of device attributes, right, you wanted that flexibility. You wanted that granularity, and you wanted to manage those states as per your requirement, right? So that's where like creating multiple shadows to your single IoT device helped you. It first of all helped you overcome challenges around cost, because now you can create small shadow documents, but the number of shadow documents can be more because there is no cost associated to the number of the documents that you create. It's still the size of the document, right? Now, once you have device state change in the shadow documents, right, there is a backend that acts upon it, right? It can be IoT rules to further process the data, or it can be any other backend AWS service or third-party service, right? Like a dashboarding integration with Tableau, or like storing the data in DynamoDB, or building a dashboard through OpenSearch or whatnot, right? So these sort of capabilities became flexible to you, right? Now, even like generally, each of these state, as I mentioned, needs to be accessed by different users or at different frequencies, right? So that flexibility also became available to you. So as a result, right, all user eventually must have access to the entire shadow document previously, but with name shadow, you can give that customization. So yeah, multiple name shadows for a service, cost effectiveness, or like generally came along with this as a part of the feature launch, and keeping it well integrated with some of the other IoT services like IoT rule engine integration and fleet indexing gave user flexibility, because many of the customers today are definitely using IoT device shadows in integration with rules engine, because with device shadow, you can maintain and manage the device attribute state change, right? But you have to have a component that actually allows you to act upon the data that you gathered, right? Or act upon the state change. So that's where like rules engine integration comes like as a native support, where you can do all the magic behind the scenes with other AWS services or third party. So yeah, these were all the set capabilities that we launched as a part of like name shadow feature. Just a pause here. Any questions so far between like classic shadows or name shadows?
I don't know if this is a question necessarily between the two shadow types, but I'm curious if you can explain maybe the behavior of the shadows. So I understand that, hey, this is a great way to either send state to the device the next time it comes online, or get the last known value of a state when the device went offline. If someone were to change the state multiple times while it was offline, so if it was a light switch, you knew last time it was connected, it was off. Someone turned it on, off, on, off, on, off, on, off before it's connected again. Do you have a method? Would those rules ever get fired, or is there any way to keep track of the amount of events that happened while the device was offline? Is that with shadows, or is that a different concept?
Oh, yes. So, I mean, all the magic that happens as a part of a device shadow service, we do have reserved IoT MQTT topics that start with the $sign. And those topics are like, these reserved topics are like for service communication. So you can actually not publish, but subscribe to these IoT device shadow reserved topics to get an update on what happened when. So yes,
Okay.
there is a mechanism for you to get updated by subscribing to these IoT device shadow reserved topics, essentially. But you cannot publish to those topics because those topics are kept reserved for these service component interactions. But yeah, there is a way. So there are reserved topics which can give you information around when the update was happened, how the update was happened, right? Whether like update was happened, whether the device was disconnected, when the device got connected. So we have like a list of reserved MQTT topics that you can subscribe to learn about those events. Yes, that is definitely possible.
Okay, but I guess maybe I missed it, but if the device was offline and multiple events happened on the device, the next time the device became online, we would be able to see those events that happened while it was offline?
Absolutely, yeah. In the order of the events that were maybe like let's consider a real-time example, right? There can be like a smartwatch and there can be a companion app, right? Maybe you are using the companion app to control behavior of a smartwatch, right? And let's say in a companion app, I'm making multiple changes to a single application that is hosted on my smartwatch firmware. Then all those things will be eventually reflected back when my smartwatch connects back to internet. So yeah, on the device side also, you should be able to see those behaviors happening.
Awesome. Thank you.
Awesome. Yeah, this was an insightful question, and I would welcome any other questions like such. Definitely helps us become more practical when we talk about things.
Oh, he'll have a bunch of them.
Okay, awesome. So as we understood how a name shadow feature can be used to resolve some of the existing challenges around cost or the way classic shadow has been implemented, right? Now then it really becomes important to understand like the different design approaches or the principles or patterns to think about when designing your new modern IoT implementation, right? And that's where I wanted to focus most of my time on that. Okay, we used to have classic shadow, we have name shadows, right? But how to essentially identify what are the right patterns for a customer to first of all identify whether name shadow will be a good fit or not. And if it is a good fit, what type of design approach I should follow based on my own use case, right? So that's where we'll be talking about three main design approach that I have recommended to my customers and I recommend to you guys as well. So we'll be going over a usage-based design approach that basically allows you to logical group these individual device attributes based on the update frequency. So depending on the type of frequency at which your device attributes are getting updated, you can create bunch of name shadows based on those frequency updates, right? The second one being like a function-based approach where you can create multiple name shadows based on the desired functionality for your use case, right? So again, depending on the use case, there are certain attributes which you may consume internally for a device study behavior. There will be certain attributes that you would want to give your users the capability to view or edit, right? So based on those functionality, you can create like a function-based design approach for your name shadows. And the third one being access control based, that really allows you to create like a data view for end user based on the desired access control pattern, right? So based on the type of information you would want your end users or devices to get visibility onto versus the type of information that you would want to just keep to yourself for admin business control and whatnot, right? So in next couple of slides, we'll be definitely diving deep into this. So the first design approach, as I mentioned, right, usage-based design approach, or you can call it like a design approach where you can club attribute based on the frequency at which they are updated, right? So it is useful for customer use cases where you are looking for cost optimizing your current IoT implementation, right? And to achieve this, you can create like name shadows, again, based on the frequency at which these attributes are updated. And how you will be doing that is because I mentioned, so let's assume like a smartwatch and a companion app use case where we have a classic default classic shadow created, right? And as you can see on the screen, there are some attributes that I would like to call out for my smartwatch, like manufacturing date, registration status, date of birth, some user information, height, weight, and then some user activity information like heart rate, calorie burns, and step walk, right? So these can be like some of the attributes that I would want to experience or track changes around for a couple of the use cases, right? Now, let's say for a single user activity, right, you would want to ensure and have a use case where you have a mechanism to get a near to real-time update on the heart rate, calories burned, and step walked, right? So based on the user activity, these will be the attributes that get updated the most, right? Versus like manufacturing date, that's like a one-time information, registration status, that's maybe like a couple of more times than a manufacturing date, and then date of birth, height, weight, depending on how many times the user actually input it or change it based on the behavior, right? So if I try to catch like the frequency, the most frequently updated attribute based on the user activity can be a heart rate or calories burnt or a step walk, right? So again, if this is a mechanism, and once these attribute changes happen, you may want to act upon the data, right? So you will have a IoT rule plugged into this device shadow where you are tracking like a change into these behavior, and you may want to push that back to your smartwatch for a user to view, right? So again, based on the update frequency, you may want to club like, these frequently updated attributes in one name shadow, and then keep all the less frequently updated attributes as another name shadow. And the reason being, every time a device update happens, right, there is a rule that gets triggered too. And when an IoT rule gets triggered, there is a separate cost associated to it, right? There is a cost associated for a rule trigger, and then there is a cost associated when the action gets triggered, where exactly like the backend AWS service get triggered as well, right? So again, if there is a frequently update on these three attributes, you don't want to keep all the information as part of one classic shadow. Otherwise, you will be always triggering the IoT rule and the backend AWS services that's connected to it, right? So by segregating like the attributes with your named shadow design approach based on usage based, you can really easily cut down on your cost. And then you will see that potential savings both on the device shadow size, because the shadow size got decreased and the frequency at which they are updating has been segregated as well. And then the effect on it will also be viewed for the IoT rule service. So, I mean, this is a recommended way to think if you are if you are looking for an easy cut down on cost, like rather than looking too much into your own use case, if it is the case, right?
I guess another question here, are device shadows the only way to send data from the device back up to the cloud?
No, not really. So there are different components within IoT core service, right? There is a message broker that actually routes the message. So there is a device gateway that basically handles the connection and communication. And then there is a message broker that essentially works on handling the MQTT managed broker that we create for you, right? So the message broker component is the component that is actually like managing the routing of messages, right? Device shadow is just helping you to manage the state of the device, right? But there is one other way to do it as well. So AWS IoT recently also launched something known as MQTT retained messages that also gives you a capability to make an update to an existing message. But right now with device shadow, you are able to track that behavior at a device level. But with MQTT retained messages, you will be managing a behavior at an MQTT topic level. So you don't necessarily associate that change in behavior per device when we talk about MQTT retained message. And that is like a native feature that comes as a part of MQTT specification. It's just that I think with the launch of MQTT 3.1.1 support, we launched that MQTT retained messages as an innate capability now, as a part to what device shadow offers. It really depends on how much granular and at what level control you want to have to those device shadow state change. And that's how you decide which one to use as opposed to other.
Got it. Thank you.
Awesome. So for the second approach that I want to discuss is again a function-based design approach for name shadows, which is when you create different name shadows based on the desired functionality, right? Now, it would really depend on how you plan to consume the collected device data through downstream application, right? And if you have those, I'm sure when you design a business, you have those functionality designed, right? So it is always an intelligent way to identify those backend downstream application patterns, and based on that, then divide like the device attribute on the different name shadows that you want to associate to your device. Right now, for the same smartwatch example, right? You may want to consume manufacturing date and registration status to send an email notification to user when the registration status changed, right? You may want to make an update to their smartwatch application when there is a user activity and a change in heart rate, calories burned, and step walked, right? And you may want to store the personal information that your users are sharing by inputting like their height, weight, and date of birth as a part of their user profile. So based on these distinct use cases, right, you may have different IoT rules associated to it. And then behind the scenes, you have like an email notification service for your first use case. You may have like an API gateway and a Lambda for your second use case, where you are actually integrating it with the application that actually running on a smartwatch, right? And for the third one, maybe you are storing as a key value pair in Amazon DynamoDB. So if you have those functionality defined, you can easily create name shadows based on those distinct attributes, because this way, again, you are not putting all the three IoT rules onto a big shadow. In traditional way, the way you are supposed to do is create three rules and associate them to this big classic shadow that's been created, right? Now, when you have flexibility to do it functionality-based analysis, you should create like function-based name shadows and then associate these individual IoT rules to these distinct name shadows that you have created. Again, the way you go with function-based design or the way you go with frequency-based design The first and the foremost benefit that you get is, of course, on the cost optimization side, right? And the second benefit that I am able to see here with the function-based design is to have a better control over on that downstream application path that you are choosing for the data to go over, right? The value and the insight that you will be gaining on the top of the data that you collected really drive the need to create these distinct name shadows for these individual devices that you connect. And the third design being access control design recommendation for customers, right? So this is true and valid for customers who are trying to understand fine-grained access control to the data that they are making their end users visible, right? In a traditional world, as we spoke about things, your end user, if you want to give them an update, or if you want to give them an capability to edit a particular information that is associated to your device, you had to give them access to the complete classic shadow, right? And now once your intention is to give them an access to maybe like change height or weight or date of birth information, right? But by default, because there was no such mechanism, you had to give complete access to the entire shadow. They may, unless you put some logic on the application side of things from the IoT core perspective, they will be able to make changes to other attributes as well, right? So we wanted to take that heavy lifting from your end to inbuild something as a part of our new offering, right? Because that's an intelligent way to do it. And the way to do it is now, based on the access control pattern that you have identified for your application, you can club your name shadows based on those, right? Now, as you can see, for the same smartwatch and companion app example, I could have like manufacturing date and registration status as a part of admin shadow that only gets visible to my application developers who are analyzing that information, maybe to understand my end user device lifecycle, right? Or maybe to understand like when these devices will expire, or to better manage like the fleet of devices that I'm offering as a part of my business offering, right? It can be consumer electronics, it can be a robot, it can be a TV, it can be a DVD player or whatever it is, right? Now, user information, again, I want to have that information consumed and visible to my end user through their smartwatch applications, right? Again, whatever I'm showing here is just an example. But again, if there are more attributes, then we can talk more granularity about the type of name shadows that you would want to create for the identified access control based design, right? So whatever we are doing in terms of recommending these design patterns, the concept remains the same, right? You are trying to create multiple name shadows for your individual devices that are connected through AWS IoT platform. But with the design patterns, we are forcing you to think more on the security side. We are forcing you to think more on the availability side, the availability of the data, and we are forcing you to think about the functionality and the end user application that you are trying to build as your end-to-end IoT solution. Now, we spoke about all three use cases. There wouldn't be a time where only like a one design pattern will be fit for your real IoT use case. It can be a mix of two as well, right? And I have seen customer doing that. I have seen customer with a requirement, I want to have a functional based design approach for my name shadow creation, but I would also like to have like a right access control in place. So if you have a combination of two, you can work with both of those things and come up with like the strategy to put like these device attributes as a part of your single name shadow documents. Any questions so far for the different approaches that we discussed?
Sure, I just have a general question. Is there an overlap between name shadows and AWS EventBridge?
Not really. So because with name shadows and device shadow in general, right, you are gaining a control on the attributes that are associated with your individual devices. These are specific IoT devices that are connected through AWS IoT Core, right? Versus EventBridge helps you track changes to your application and then build like, like an event-based architectures on the top of it based on other AWS services. But like device shadow and name shadow are specific to IoT Core service, I would say. Does that make sense?
Yep, thank you.
So now, as we discussed, like the name shadow features and the different design approach that are made available to you guys to play with the new feature and to basically implement or migrate away from your existing classic shadow design to a multiple name shadow design for your connected devices, right? So I really now wanted to get into like a customer use case where a customer, one of the largest customers of AWS IoT Core, iRobot, they recently did this migration and they migrated away from their existing classic shadow use cases to multiple name shadows for their individual robots. I quickly wanted to go over those for this part. So the way they did was they already had like their robots that are out in the market. People are buying new robots every day. Their architecture is in place. They are using like a combination of a serverless and IoT offering. And they are creating classic shadows, right, for these robots that are robot vacuums, right? Now, once the name shadow feature was launched, right, the way they plan to go into the production was by like sharing that name shadow support through a over-the-air firmware update to their field robots, right? Now, these vacuums are the vacuums that user already have purchased and they are up and running in their individual houses. Or these can be robots that are sitting out on shelf, but would be eventually bought by an end customer, right? And once they initiate like a registration process or the first time the user turn their robot on, it initiates a user registration process, right? Where their Roomba vacuum cleaner is getting connected and registered to their AWS IoT backend, right? So there was already a registration process in place. So I worked with them to intelligently identify on how you can use the same mechanism now to migrate away from classic shadow to name shadow. So the flow that I'll be discussing here is based on the existing registration process that they have in place for any Roomba vacuum that's get connected to AWS IoT platform, right? So to initiate the migration process, right? So a firmware update was sent to these robots, as I mentioned, through over the air firmware update to support name shadows, right? And after receiving this update, each robot will now follow a normal robot registration process. And in order to follow this update and this update in the OTA, then invokes like a API gateway, right? It invokes an API call to register these robot through API gateway service, which now also includes an event that lets them identify that a name shadow support is available, right? So this API now is backed by a register robot Lambda function, which consumes this event, which is sent eventually by the robot device through API gateway to this Lambda function, right? Now, after learning the support for Lambda function, the register robot Lambda, it fetches the current classic shadow to understand if a migration is required or not. And the way they architected it was a flag was placed within these classic shadow documents that would indicate this register robot Lambda function whether a migration is required or not, right? Now, why these use cases, right? Because if a robot is already out in the field, that means it is already connected to AWS IoT platform. That means it has already been using classic shadow, right? But if a robot was not in the fleet right now, right, is not connected ever, it not even have been turned on, they would directly have a name shadow support. So you don't need a migration. So in order to identify the robots that actually need a migration and a robot that doesn't need a migration because there are new robots, they have placed a flag within these shadow documents to indicate, basically, right? Now, if a migration is required, right, then the Lambda function insert a second flag into these both classic shadow and name shadow document so that this robot is not flagged as a new robot. Because if this robot is flagged as a new robot, then either it will already have a name shadow support or there is a separate registration process that needs to occur first before thinking about migration, right? Because this is the first time a vacuum is connecting to internet, right? And to AWS IoT platform, essentially. So as I mentioned, like if a migration is required, then the Lambda function insert a second flag into the classic shadow so that the name shadow is not tagged as a new robot. Now, this register robot Lambda function will then publish will then publish like the message to a simple queue service, which will eventually get consumed by a second Lambda function. That is like a new Lambda function that they created to migrate away from classic shadow to name shadow. And this Lambda function does the heavy lifting to actually complete the migration that we will just talk about, right? So after the name shadow migration Lambda function receives the event to actually execute the migration, what it then does is it operates, so the step 9 and 10, it operates parallel to the step 7 and 8, right? So the step 7 and 8 happens when the firmware update is completed and the robot vacuum is first time getting connected to the AWS IoT MQTT broker, right? So when it is connected to MQTT IoT broker, a classic shadow is creating for it. And if it is a new robot, then it will have a name shadow support. So the name shadows will get created for that new robot as well, right? So this steps happens in parallel to the step of name shadow migration Lambda function, where this Lambda function actually fetches all the data that is not new, that is not recently posted by these Roomba vacuums, and take all the old stale data and transform it to the multiple name shadows that are being created for that existing robot vacuum, right? So the entire migration is then completed by the name shadow migration Lambda function. And once the migration is completed, right, the same Lambda function also toggle like the flag in the classic shadow document and the name shadow document that the migration is completed. And once the entire data has been fetched to the current classic shadow and it has been placed to multiple name shadow, it also, the same Lambda function also erases the stale data from the classic shadow document, because if it is still there, then the same process might occur in loop, right? So to remove like additional iteration of loop on the same data, right, it just plays that additional logic so that, like, you know, it's a one-time process where like all the stale data is being transferred out from classic shadow and is being placed to the multiple name shadow that has been created for these Roomba vacuums, right? Now, one thing I wanted to mention is, as a part of the device shadow service, right, and as a part of the offering that we provide with classic shadow and name shadow, we do have API calls available, right, that are being used by these Lambda function to actually do the magic, right? So this is a service. We have API calls available that you can use those API reference calls to actually make that call happen based on the use case. So just wanted to mention that we do have APIs available to interact with both classic shadow and name shadow that can be used within your Lambda function logic to actually execute the migration. And this is how, I mean, iRobot was able to migrate their classic shadows to name shadows in real time, right? While their robots are operating in production with essentially zero downtime, because we are not making any changes to the active data that is being consumed through the app and whatnot. It is just like the data that is being old stale, and we are consuming that data and transforming it to the multiple name shadow support that now comes with each connected Roomba vacuum as a IoT thing. I'll just take a pause here. I know it is a lot to consume. It has an entire flow, but yeah, I'll just take a pause to see if you have any questions here.
With an architecture like this and with some of the limitations of IoT devices, I think, you know, something that's different with IoT versus your typical client server application is a device that hasn't been online in 10 years might decide to pop online one day. Is there any, with an architecture like this, do you ever have the opportunity to say this migration is complete, or due to the variable nature of devices potentially connecting 10 years down the road, is this a service that's going to have to run indefinitely for the life of iRobot going forward?
So as a customer, right, if you have a way to understand how many devices or what is your IoT fleet basically, right? So again, there are mechanisms within IoT Core that allows you to keep a track of devices, right? And you can build custom metrics to understand what your current device count looks like, right? So if you have a mechanism to keep a track of how many devices are part of your IoT fleet, then yes, you can essentially comment on whether a migration is completed or not. But for that, you will have to take on a heavy lifting to control the field devices, because as a user, right, you can connect your device fleet to AWS IoT, but you decide not to give them some unique credential, right? So there isn't any way for IoT Core to understand that behind the scenes nature, whatever you are doing with your devices, right? So if there is not a real way for AWS IoT Core to understand that how many devices are connected, we cannot control that for you. But if that is not the case, then you as a customer need to control those number of devices that are connected. And if you are able to view and comment on the metric, on the fleet of devices you have, you can say. But I agree to you. If you don't have a way to control it, and you have something placed as a part of your registration process, then yeah, it can pick up an old device that is connecting after 10 years just for the continuity of it, just to ensure that at the end, like, we shouldn't be having any complaint for a customer that, I am not seeing a desired behavior out of the companion app or a home app that I'm using to control and manage settings on my Roomba vacuum cleaner, essentially. Does that answer your question?
Yeah, absolutely. Yeah.
Awesome. So yeah, that was all from my end in terms of like the capabilities that I wanted to talk about, and a real life example from a customer iRobot. But yeah, I'll just take a pause here. Again, we can use this time to chit chat anything that you are doing with AWS IoT Core and you may have questions of. I'm happy to answer any one of those questions as well. I'll just stop my screen share now.
I want to give other folks an opportunity to ask questions, but I do have another question, maybe to fill some time in the meantime. So something that I'm struggling to wrap my head around a little bit, and I can probably go and read the docs and maybe it's a bit more clear, but I'm trying to understand. Previously, up until joining this call, I had thought of these device shadows as like configuration options for my device. Seeing things like manufacturer date, firmware version, things like that made sense to me. Seeing this used for heartbeat data or real-time data, I would have expected to use MQTT for that. And so I guess, was that just an example to show, hey, this is a data set that would be updated more frequently? Or was that a real world example that makes sense?
I would say that was a real world example. We are seeing customer using device shadows to gain a complete control over the device settings and the data and the attributes, right? So we are seeing like heavy usage for device shadows, where customers are using it to gain control over the device setting. Because before this, as you mentioned, right, MQTT has a way to use retained messages as at an MQTT topic level, right? But that was not by default supported within AWS IoT Core. And so yeah, new customers, they have a flexibility to choose from, right? If you want to give an update to a message at a topic level, you can use MQTT retained messages. But you want to tie that update back to an individual device that is connected as a part of your fleet, use device shadow, because MQTT retained messages don't have a way to do it, right? So it's basically controlling behavior, right? So if you ask me like what type of customers are using it, right? Consumer electronics customers are definitely using it. Industrial customers are also using it, right? Because there are use cases where you want to understand the behavior of a particular device, right? For predictive maintenance, for firmware updates. Also, you may want to either directly do firmware update by understanding that behavior, or you want to understand your fleet of devices from last 5 years and try to gain an understanding of how they are behaving, right? And the way you do it is by building dashboard on the historical data that you can gather through device shadow, basically. So yeah, a lot of the capabilities are uncovered when you integrate device shadow with something else, right? That's the part of the nature, because device shadow is helping you to manage, and you can consider it as a persistent storage option within AWS IoT Core, but eventually the data has to land, right? Based on the use case. It can be a DynamoDB, it can be a Lambda to further act upon on data. It can be CloudWatch to gain behavior or watch a metric. It can be Tableau. It can be Redis for caching, in-memory caching and whatnot. So yeah, but device shadow is being heavily used because everybody wants to understand the behavior of the devices that are out in the market, because that has a purpose, right? And IoT is most used and consumed when you have a true value coming out of the data that you're collecting. Otherwise, why would you pay for collection of the data?
Yeah, I agree. I guess I'm learning I must be doing something wrong, or there might be an easier way to do something, because I'm sending all of this data out and reporting on all of it, but not using device shadows. And so this is insightful to me. I'm excited to kind of go and dig a little bit more and see if I can use that tool to accomplish the goal that I'm trying to solve.
Absolutely. Yeah, no, and it natively integrates with many other IoT core capabilities, as I mentioned, right? Like IoT rule that gives you opportunity to filter the data or the messages that you have gathered and then send it as a stream to Kinesis or send it to DynamoDB and whatnot, right? And it also integrates with fleet indexing. So with fleet indexing, you can actually build search capabilities based on the device behavior that you are noticing, right? You may want to have a capability to search a device based on the firmware version they are operating on, right? So you can actually keep a note of you can send firmware version as one of the attributes from your devices, and then you can basically create like a fleet indexing basically create an index on these firmware versions, right? And then you can analyze how many of your devices are on a particular version, how many are on Y version, how many are on Z version. And based on that, you want to take a further action. You may want to upgrade an older version to a newer version. Then there is the entire backend stream that can handle that heavy lifting for you. And scale is another factor, right? With AWS IoT Core. I mean, talking about like customer like iRobot, they have like 10 million plus devices connected as a part of their fleet, right? And they are exchanging billions of messages every day. So to achieve that level of scale, it becomes easy as well, right? So that's another aspect to it.
I have a quick question about IoT Core server initiated disconnects. I understand that by reading the documentation and talking to support that it is something that is out of control or something that we cannot control, right? Do you have any recommendations in terms of cost reductions from distinguishing server initiated disconnects from true device disconnects? Because while you can filter within the rule to not trigger specific actions, the cost of the rule is still passed on to the customer.
Okay. So if I'm understanding it correct, you are saying that disconnecting and connecting back to AWS IoT Core, it incurs you charges because charges are based on the number of connections that you are creating with IoT Core, right? And now you are saying that there are times where the disconnect is being initiated from server side, right? And then they
Correct.
become, okay, and then you are getting charged for a reconnect again, right? So, I mean, if I think right now on the top of my mind, you can definitely build custom metrics, because if it is a server initiated disconnect, it will be coming as a part of your logs, right? As a part of your IoT CloudWatch logs, right? So maybe building a dashboard on the top of it to distinguish like 5xx errors or disconnects from 4xx disconnects, and then acting upon that to at least have a metric on how many disconnects were from the service side of things. To understand that behavior and pattern is something that I can think of. Again, there can be other ways as well, but most of them will be built on the fact that the information, through the CloudWatch events and what. So, yeah.
Perfect. I have another question, actually. You mentioned earlier that you've seen customers use device shadows for heartbeats. Is there a reason why you would do that versus using the built-in life cycles?
Oh, no. So heartbeat was specific to a user activity. I was giving an example of a smart watch and a companion app, right? So that heartbeat was a user heartbeat. So if I have a smartwatch on my hand, right? So if I walk, so sorry for the confusion. I should have used a better terminology. Sense. But no, you are absolutely right. You should use like the life cycle policy to manage that and to maintain that.
Yeah.
Yeah, I never thought about it. I should be better at messaging or maybe change that attribute to something else.
It's funny though, the heartbeat though for a heartbeat caught my attention for a different purpose, and it prompted a question specifically about that type of data which updates frequently. So whatever attribute you replace it with, I hope that it is updated as frequently as perhaps heartbeat.
I know. Awesome.
Nice. So have we run out of questions? think we have. Chris, you got some more? You sure? You dry?
Well, all right. So I mean, I'll do one more if we have to. So I was poking around my AWS account. I didn't want to say anything that I didn't fully understand. So full disclaimer, I spent doing a bunch of POCs in IoT probably 6-8 months ago, and I actually pinged you on LinkedIn and you helped me with some context. Since then, I've been working on board bring up and this, that, and the other. I haven't been into the fleet provisioning. But when I was in there, I realized that I was primarily using these topics. I was using the topics to go out to rules. And I was doing everything that in your presentation today, you're showing with shadows and classic and name shadows. I was doing with topics and rules. And I don't think that there's going to be a hard and fast answer to when to use one or the other. I think part of the answer I heard you say earlier was, hey, some of those features weren't always available. But given that they are today, is there a clear reason when you might want to use a topic versus using a device shadow?
Yeah, sure. So a couple of things that I could think of is, as I mentioned, right? So with device shadows, one of the attributes that we publish for every shadow change, right? For every attribute change is a timestamp. So there is a timestamps that get published to a device shadow state change, as opposed to there is not there is no timestamp with the MQTT retain messages feature. You don't have a timestamp. So if you have a logic that is based on the time at which a particular change occurred, then you may want to use device shadow as opposed to MQTT retain message, right?
Okay, because just to wrap my head around this, one of the rules that I have today says take from my topic, parse the time out of that, and then throw it into an Amazon time series database. But that's the time that I received the message, I believe, not the time that the message is created.
Exactly, then the state was changed. Yes.
Okay.
And
so some of those, okay.
Yep. And the second example would be with device shadows, it gives you a capability to track changes as a desired state and as a reported state, right? So you can basically, if there is a application and a device interaction, and you want to track like what was the desired state and what was the reported state, right? If you want to have that level of state monitoring, then you can use device shadows, because when you do the monitoring with MQTT topic, it doesn't let you control that behavior. That what was it? It just gives you the latest updated message, right? There isn't a way for you to understand what was the previous state and what was the next state. So if you want that level of logical understanding, then you may want to use device shadow as opposed to MQTT retain messages. Does that make sense?
That does, and that's actually relevant to some of my use cases. So I appreciate that, and that helped me wrap my head around it. I've been spinning for the whole presentation about what am I doing wrong, what am I doing wrong, but that helps me wrap my head around it. So thank you for that context.
Yeah, but I wanted to give like a little bit more generic information around device shadow, but it would have derailed the conversation to talk about name shadows, and I thought that maybe we can cover that some other time.
I'm always good to derail a conversation. I apologize and thank you.
No, absolutely. This is good. This is good. It definitely gives me a context on, like maybe there can be better wordings, because we recently started to support MQTT retain messages as well, right? I mean, it was like a year back or so, and then we had, maybe there is like a better documentation or a way to help customers understand when to use what could be more helpful. Definitely, point taken.
There's no derailing conversations. This is what community time is all about: hanging out and sharing ideas.
Absolutely.
The beauty of virtual is that you'll be able to get home at a reasonable hour. I'm not going to keep you from leaving. So one of the benefits here, but I assure you that is the last of my questions.
And not drive home in the snow.
Yeah.